Hi everyone, and thanks for joining me. This series of videos is going to cover the changes to the 2020 National Electrical Code. And the topic for today's video is 110.14 Electrical Connections. The rules for copper-clad aluminum conductors were clarified, the rules for tightening terminations were revised, and 3 new informational notes were added. So a few interesting things here, and when we get into 110.14, this is the general requirements for electrical connections. So I think we can all agree that this has to be one of the most important sections in the entire codebook. Usually when we have a failure on an electrical installation, it doesn't happen in the middle of a conduit. It happens at a splice, at a termination, at a connection to equipment. So connections are critical, and I think we all agree with that. So 110.14 gives the basic requirements for electrical connections. So this really is a section that we all need to know and know quite well. So from the top, it starts by saying that devices like pressure terminals or splicing connectors have to be identified for the material of the conductor and be properly installed and used. Now, I italicized the word identified in that statement because it's a defined term, and it's one that gets misused rather often, both by people in the industry and unfortunately sometimes the code doesn't use it consistently either. I think this application is the correct usage of the word identified. It does not mean marked. It simply means this is suitable for that. So in this instance, it's saying, look, your connector, your terminal, your termination equipment has to be designed for, has to be suitable for the material of the conductor. So if you're terminating copper, we need to use terminations that are suitable for copper. If we're terminating aluminum, then we need to use terminations that are suitable for aluminum. And we couldn't possibly understate just how important that requirement is. We need to make sure we're using the right fittings, and they have to be properly installed and used. It goes on to say that connections of copper to aluminum or copper-clad aluminum to aluminum must only occur in terminations that are identified for those dissimilar metals. So if I'm terminating copper to copper, then that's fine. If I'm terminating aluminum to aluminum, that's fine. But when we start getting dissimilar metals, that's where things can become problematic. We get galvanic action and galvanic corrosion when we touch aluminum to copper. So the clarification here is that copper-clad aluminum must not touch an aluminum conductor unless it's identified for those dissimilar metals. Now, taking a look at the photograph here, we have an aluminum conductor touching the steel terminal, and we have a copper conductor touching the steel terminal. So this would need to be designed for both copper and aluminum. It does not have to be identified for copper touching aluminum, because copper is not touching aluminum in this photograph. The lug would just have to be marked AL-CU, for example. If we had actual copper to aluminum contact, or copper-clad aluminum to aluminum contact, then the fitting would actually have to say AL-CU intermixed dry locations only. It has to have that whole big phrase according to the product standard, otherwise it does not comply. So this doesn't have that marking because it doesn't need to. But I want to get back to the change here, and that is copper-clad aluminum. So copper-clad aluminum was something, it's actually been around for an extremely long time, but it kind of picked up in popularity in the 70s. And then it more or less died off. And the idea of copper-clad aluminum is exactly what it sounds like. It's an aluminum wire with a copper perimeter around it. In fact, here's a photograph, same conductor, and we just kind of scrape the outer surface with our knife. You can see that it appears to be a copper conductor, but underneath it's actually an aluminum conductor with copper metallurgically bound around the aluminum. Now, why on earth would you create a conductor like that? It's actually a pretty good concept if you think about it. If I look at the ampacities of conductors, as I get larger in conductor size, there is a huge diminishing return. Let me show you what I mean. We have 500 kcmil copper, and at the 75 degree column, that is a 380 amp rated conductor. Now, if I were to make that conductor 400% larger, 4 times larger, would I increase the ampacity by 400%? And the answer is not only no, but it's actually not even close. As I go down, 2000 kc mil is only good for 665 amps. That's not a 400% increase, it's a 59% increase. And the reason for that is that the effectiveness of a conductor really isn't the overall area, it's the perimeter surface, for the most part. So most of the current is traveling on the perimeter surface due to skin effect and eddy currents. So it's the perimeter that really matters. So the inside of the conductor is not nearly as important as the outside surface of the conductor. So why not use aluminum, which is a good conductor? It's not as good as copper, but does it really need to be as good as copper as long as the outside is copper? It's an interesting discussion point. Smaller conductors like this, the discussion's not that big of a deal. If we had larger conductors, then I think this could really be a great point to argue whether the inside of the conductor is as important as the perimeter. Now, if copper-clad aluminum was only around in the early 70s and then it just died off and nobody's seen it ever since, then I wouldn't waste your time talking about it. I think it's interesting personally, but if it's something that you're never going to see, then why would we waste our time? The fact of the matter is, copper-clad aluminum is almost certainly going to be making a comeback. In the 2023 version of the NEC, which we're in the middle of the development process right now, it appears that we're going to allow more uses of copper-clad aluminum. So I wanted to kind of let you guys know what the rules are for copper-clad aluminum. And if we go back to it, connections of copper to aluminum or copper-clad aluminum to aluminum. So copper-clad touching copper is fine because that's copper touching copper. It's copper-clad aluminum touching aluminum that would be problematic. So we need to make sure that we're using the right fittings anytime we make terminations. Now, the other thing that happened is in 110.14d, and that's having to do with torquing our terminations, a very important concept. If a terminal has a tightening torque indicated on it or in its instructions, then the terminal must be tightened to that value in an approved manner. All right, so the concept of torquing our terminations is certainly not new. For decades, we had an informational note here that just told us, listen, some equipment has a tightening torque and you need to follow instructions. And that was the end of it. It wasn't necessarily a requirement, just a reminder that some equipment does have a tightening torque. Now, how were you tightening your terminations before the torquing was a requirement in this section? Well, to be honest, it's always been a requirement. We have to follow the manufacturer's instructions if we're using listed products, and the manufacturer's instructions told us to measure for tightness, to measure for torque. So this isn't exactly a new concept, but it's really being emphasized, and I'll tell you why this is being emphasized. Kind of an interesting story. I have a friend of mine named Crystal Hunter, and she is absolutely brilliant. She knows everything there is to know about wires and terminations. That is her world, and she's very good at it. So she did kind of an experiment. She went around the country, and she had this piece of wood that she created, and she had all these lugs on it. And what she would do is she would travel around with little cutoffs of conductors. And she would test electricians. She'd say, hey, here's a piece of 500 kc mil or a piece of 1/0 or whatever it was. And she'd say, here's the lug for it. The correct tightness is 25 inch-pounds. And I'm going to give you a ratchet or an Allen wrench, whatever you want. And I want you to go ahead and tighten it like you normally would. And we're going to see just how accurate your eyeball and your muscle memory is. We're going to see if you actually tightened it even close to what it's supposed to be. So if it says 25 inch-pounds, we're going to give you a passing grade if it's within 10% too loose or too tight of 25. So I guess that would be anywhere from 22.5 to 27.5 inch-pounds would be a passing grade. Now, She's done this test all over the country, and the results are pretty consistent. And I was very surprised when I found the results. I've taken her test, by the way, and I'll tell you that I didn't pass. Her test results showed that 60% of electricians are under tightening their terminations. And then another 20% are over tightening the termination. So that means 1 out of every 5 is doing it right if they're not actually measuring for tightness. And as I stated at the beginning of this video, terminations are one of the most important concepts of the entire installation. We need to make sure we're doing them right. So her research really brought this issue to the forefront. And when her work was published, and by the way, it's available online, you can find it, if I'm not mistaken, it's in an IAEI article, International Association of Electrical Inspectors. But research her work, and I think you'll find it fascinating. I certainly did. But it really made people aware of the fact that people are not doing this right. So we need to make sure that we're measuring torque. This individual is working at a prefab shop, and he is torquing the terminations. As you can see, he's using a properly calibrated torque tool. Now, the dangers of under-tightening probably don't really need to be discussed too much. Under-tightening is a loose connection, and we know that that's going to create a high impedance, perhaps an arc. Here in the photograph, this termination is quite literally glowing. Now, did this termination say 25 inch-pounds, and this is what it looks like if you terminate it to 24? Probably not. I doubt this was ever even terminated at all. Probably just pushed in there and not tightened. But we do know that under-tightening is a major problem. Now, the way some people solve it is instead of measuring for torque, they just crank it down until they hear something crack. I mean, I've taught all over the country, and I've heard people say that. They say, well, I don't need to measure it. I just push it down as hard as I can, and then I get my buddy who's the bodybuilder, and I have him give it another crank on it. And it's important to remember that, under-tightening is bad, but over-tightening isn't good either. We're looking for that Goldilocks zone where it's not too cold and it's not too hot and it's not too soft and it's not too hard. We want these things to be done correctly. So we need to torque it down properly. Now, previous versions of the code in 2017 said you have to tighten it down and use a properly calibrated torque measuring tool. And that was revised for a couple of reasons in the 2020. First of all, when you read it, you tend to focus on the properly calibrated tool part instead of the rule itself that says, hey, make sure you're doing it right. Plus, do we really need to say that the tool has to be properly calibrated? That kind of goes without saying, doesn't it? You don't measure things with improperly calibrated measuring devices. I don't think we need to talk about that. That's pretty obvious. So, of course, it needs to be properly calibrated. So what they did in the 2020 is they said, look, do it in some sort of approved method, because measuring it with a properly calibrated tool is not the only way it can be done. Now, the note says approved ways to achieve the proper torque could include using torque measuring tools, and that's what we have here in the photograph. That is the torque measuring screwdriver that the individual in the prior photograph was using to tighten down that circuit breaker. That is a torque measuring screwdriver, and that would be a great way to check tightness. But we could also use things like a shear bolt or a breakaway device. If you go into a large commercial building that has structural metal, if you look around at all the red iron, you might notice at all the high strength bolts, if you get there during construction, when they're putting in the high strength bolts, there's a little nub on the end of the bolt. And if you see this little nub, that means that it was not tightened correctly. And that way the building inspector can walk around and from a mile away, he can see any terminations that weren't done correctly, these high strength bolts. And the reason that he knows it's not done correctly is that little nub snaps off when it's been tightened appropriately. So then we know we don't have to measure it. The iron workers can just crank it down until it snaps, and then we're good. Now, do they have such connections in the electrical industry? I'm led to believe that they do. There's some manufacturers of switchgear or motor control centers where the horizontal bus, where you might have to bolt the busing together, they might employ shear bolts like that, where the end of it snaps off when you've tightened it correctly. And we can all agree that tightening our bus bars together appropriately is critically important. Breakaway devices, like I talked about, there's other methods as well. I'm led to believe that there's a busway product out now. I'm told that it's by Eaton, but I haven't seen it, so I want to be clear. But there's a busway product where when you bolt the busway together, when you crank it down to the appropriate tightness, the bolt head actually will change color, like from red to green or green to red, letting you know that you've achieved the proper tightness. So measuring things with a measuring device is not always appropriate. We just need to make sure that we're tightening things to their specified torque. Another informational note lets us know about Annex I in the back of the code book. It says Annex I provides torque values that can be used if the manufacturer does not specify a value. Now, in the photograph, I'm showing this as an example simply to point out that most things will have a torque rating. Here on this screw, it says torque it to 35 inch-pounds, and this is just the main bonding jumper screw for a panel board. If the main bonding jumper screw for a panel board has a torque rating, you can pretty much bet that your circuit breakers and your lugs and even your devices are going to have a torque rating. But if you genuinely have no guidance whatsoever, then I would tell you to check with the manufacturer, go to their website, see if you can get information there, and then as a last resort, if you, again, have no guidance whatsoever on how tight it's supposed to be, as a last resort, go to the back of the code book in Annex I, and it gives some very generic values that could be used if you have no other guidance. The last thing that they did is they added informational note number 3, which I found very useful. It says additional information can be found in NFPA 70B, which is the recommended practice for electrical equipment maintenance. All right, so if we look at this photograph, we can see what probably happened here is somebody tightened it appropriately. If we focus on the aluminum part, somebody probably tightened it appropriately and then marked it with a Sharpie, with a marker, saying that it was marked, that it was torqued properly, and then somebody came back and gave it another half turn. Now, is that recommended? The answer is absolutely not. The correct procedure for making a termination is to do it once, and do it correctly, and then leave it alone. Unless there's actual signs of degradation, then you leave it alone. And that's what the informational note here is talking about. It says take a look at section 8.11 of NFPA 70B. Now, I don't own a copy version of NFPA 70B, but I can tell you that if you go to NFPA Link, you can get all of NFPA standards online. Now, the goal from NFPA is to have every single one of their product standards available by October of 2021. And I think that's going to be amazing because a lot of these standards I would never have purchased, but I would like access. It would be nice to be able to read the standard for fire pumps, but I don't do enough fire pumps that I can justify buying it. Well, now you don't have to, and I'm hoping this doesn't sound like a sales pitch. If you don't want NFPA Link, don't buy it. I don't care. But it's $10 a month for an individual user, and it's even cheaper if you do like a group package. So for $10 a month, you get access to the NEC, and for me, NFPA 70B and NFPA 70E, all of which are very important to me. And if you're watching this video, probably important to you as well. But I also get access to all of these other NFPA publications, including prior versions of the NEC, the 2011, 2014, 2017. So if I remember the informational note, it said to take a look at NFPA 70B, and it even tells me to go to section 8.11. So I'm going to open 70B, go to chapter 8, 8.11, and it actually gives me some very useful information. The initial installation simply tells me to use a calibrated torque measuring tool and to install it correctly. But 811.2 and 0.3 are where I think it's very interesting. 8.11.3 tells me how to check for tightness when there are no signs of degradation. This gives some very useful information, and I'm going to go back to this screen here and just kind of paraphrase it. So, paraphrasing 8.11.3, it says after a connection is torqued, there can be metal relaxation. So it's not appropriate to check tightness to the prescribed specified value. Doing so can cause damage and might void the listing. One industry practice is to check terminations at 90% of the specified torque value, and if the screw or bolt does not move, it's considered properly torqued. So let's talk about that. If my termination says 25 inch-pounds, and you tighten it to 25 inch-pounds, if you come back in a couple of days and check it again, it probably will not be 25 inch-pounds anymore. And that's called metal relaxation, and it is understood and it's expected. The manufacturer knows that's going to happen. Let's remember something. The manufacturer of the termination knows a lot more about terminations than any of us do. That's their whole world. So here's what's fascinating. When a manufacturer tests a product and they figure out the perfect tightness for it, where they get peak performance, let's say that they test it and that perfect number is 23 inch-pounds. Do you know what they'll mark on the product? They'll mark 25. Because then when you put it to 25 and come back a couple of days later, it will be 23. But that's what they wanted. So if you do it and you keep on checking it, and it's like, geez, I keep cutting it and every time it's still too short, right, stop cutting it. Terminate it once and then leave it alone. So if you go into an existing installation and there's no signs of degradation, you shoot it with a camera and with thermography and it doesn't appear to be problematic. If you just want to maintain things, that's fine. When it's shut off, obviously, you want to check it. If you click it to 90% and that screw hasn't moved yet, that means it's time to stop. There's no reason to go all the way to 100% of what the manufacturer recommends, because the manufacturer really didn't want you doing that. They wanted you to do it once and do it correctly and then leave it alone. So when it comes to terminations, terminate it once, terminate it correctly, and then leave it alone. And if there's no signs of degradation, then we should be perfectly fine. Now, if you look at a termination and there are signs of degradation, then go to NFPA 70B and you can find out what sort of remedial actions you can take at that point. But what we don't do is just walk into a facility and start tightening everything down as tight as we possibly can. That is not the correct solution. Do it once, do it right. Be sure to like, follow, subscribe, and ring the bell.